All right, so now that we know that the p-value is 0.0801, we have to make a decision. And the answer to what decision we make is that we are not going to reject the null hypothesis. The reason being is that the p-value, which is only 0.0801, is not less than the alpha, and the alpha was 0.05. Therefore, we can't reject the null hypothesis. That means that there is not enough evidence to support the claim that the proportion of consumers' energy customers who are very satisfied is different than 80%. We wanted to get evidence to show that it was not 80%, but we didn't get enough evidence to do it. Doesn't mean that it is 80%, it just means we didn't have enough evidence to prove otherwise. All right, let's redo with steps 4 and 5 using the classical method. All right, so first thing I'm going to do is I'm going to go grab the picture of the classical method, which is right here. There, the classical method one. Okay, hold on one sec. All right, there it is, large enough for you to be able to see it. Now, notice that the critical region here is split in two, and so you have alpha over 2 on one side and alpha over 2 on the other side. So let's think about what that means. If alpha is 0.05, then this is alpha over 2, which is 0.025, and that's for both sides. That's why the critical values say z alpha over 2 for both of them, okay? So how do you find those? Well, this is something StatCrunch doesn't do for you. You're going to have to go do it in Excel. So let's take some moments over here and let's figure it out. So alpha I already have right here. It's right there. It's 0.05. So what's alpha divided by 2? That would be equal to 0.05 divided by 2. I already found z0 both ways, lower and upper, and now I'm going to find z alpha over 2. All right, this is going to be equal to norm dot inverse, or norm inverse, not without the dot if you have older Excel. The probability is, you can do this two ways, but I'm going to do 1 minus 0.025, because what it really is 0.975. Or if you really want, you can actually do just 0.025, comma 0, comma 1, comma true. Oops, not comma true, I'm sorry. 0, comma 1, there you go. That's the lower one. So this is the lower, and then the upper will be z alpha, here, hold on, upper, oops, upper, which is equal to the negative of that, the opposite. And again, you could have done this a couple ways. Like I could find it by taking the negative, or I could find it by taking what I said before. I can watch equals norm inverse. Again, you don't need the dot if you have the old school. 1 minus 0.025, comma 0, comma 1. There you go, it's the same number. So there's a lot of ways you can do it. So there are your two critical values. So let me go back here. Oopsie, not there. Here, haha. Okay, so we have our two critical values. We have negative 1.96 over here, negative 1.96, and we have positive 1.96. Now those should not be coming as any great shock to anybody, because they're the same critical values that we found in chapter 9 every time we were dealing with a 95% confidence level. And if alpha is 0.05, then you've got 95% in the middle, right? Right. All right, so there you go. So then we don't reject again, right? Do not reject H naught, but for a totally different reason. We're not rejecting H naught because, oopsie, because our statistic, which was, I better go find it, Z0, which was negative 1.75. And cut out the middleman here and make it negative 1.75, is not in the critical region. Hold on 1 second. There we go. The critical region's that dark tail areas. Hold on. There we go. Got it to type the way I wanted to. In other words, it's not lower than negative 1.96 or higher than positive 1.96. It has to be in those dark tails in order to reject the null hypothesis. You got to be in the critical region, i.e. past the critical values. And since you're not, then you're not going to reject. All right, so that's the end of that portion with the classical method. I'll be back to talk about the confidence intervals.